Lesson 49, 9-1, rational functions. We talked about rational functions and what the graphs look like. Biggest thing is when graphing a rational function, your equation here, your denominator cannot equal 0. You cannot divide by 0. So this denominator here cannot be equal to 0 as stated here. In order to figure that out, you need to figure out the excluded values. Basically, when setting the denominator equal to 0, you'll find out what the excluded value is for the rational function. Asymptote. An asymptote, we'll find out vertical and horizontal asymptotes. Basically, that is a line in the function that it never touches. Your graph will approach it, but the graph will never touch it. Kind of like there's an infinite amount of numbers. Therefore, the graph is actually going to go on forever and ever and ever, and it will never touch your vertical or horizontal asymptote. In example 1 and 2, we're going to work on finding the excluded values. Remember, in order to find the excluded value, you want to set your denominator equal to 0. So if we look at this first example, here's x. If we set x equal to 0, the equation is basically solved. That is stating that x cannot be 0, because if you put 0 in for it, you would have -2 divided by 0, and if you would check that out on your calculator, you would have a divide by 0 error. So x, in this case, the only excluded value is 0. So 0 cannot be used for x. Example 2, again, here's your denominator, 4x minus 8. That is what we'd want to set equal to 0. And when you solve it, it's just like solving equations. So we would add 8 to both sides. We'd wind up with 4x equals 8. Get x alone, divide both sides by 4. And we find out x equals 2. Again, what that is stating is that x cannot be 2. So if you plug 2 into your equation here, you'd have 4 times 2, which is 8. 8 minus 8 would give you 0. So the excluded value in example 2 is 2. The second part of our assignment involves the excluded values, and this is how you would find the horizontal and vertical asymptote. This box here will be a good resource for you to use. Kind of like every equation, you have a slope-intercept form, y equals mx plus b, your quadratics. Well, the rational function equation, general equation, is y equals a divided by x minus b plus c. Within this equation, you're able to find out your vertical and your horizontal asymptote. Your vertical asymptote, right here, we are going to find out from your equation. In order to find out your vertical asymptote, basically what you're doing is what you did in examples 1 and 2 when you found the excluded value. So what you'd want to do to find a vertical asymptote is take your denominator and set it equal to 0 again. So basically x makes the denominator 0. We want to figure out what should we not put in for x. And again, to do this, set it equal to 0. So you have x plus 2 equals 0. Subtract 2 from both sides. X equals -2. Is x equals -2? Yes, -2 is an excluded value. It is also your vertical asymptote. So when you graph this, x equals -2, it's telling you that it crosses the x-axis at -2. So I'm going to go ahead and I'm going to graph my x equals -2. And here's where x equals -2 right here. That is your vertical asymptote. Remember, a vertical asymptote is basically your line. When graphing your rational function, it will never touch that line. It will approach the line but never touch it. You also need to find out your your horizontal asymptote. And according to the information up here, to find your horizontal asymptote, y equals c. So note where here's y, here is c. So is anything added or subtracted? We look at our equation here, nothing is being added or subtracted. So when we find our horizontal asymptote, y equals c, Nothing's there, so y is equal to 0. So we are going to go ahead and graph that. Crosses the y-axis at 0. Here it is, crosses the y-axis at 0. Now you have your horizontal and your vertical asymptote on your graph. Next, we're going to go ahead and we are going to graph our equation here. So we need to come up with points. The big key here is your vertical asymptote. Normally, when you plug values in, you have an x input, a y output. Remember, we cannot put in -2 because your denominator is going to be equal to 0, and we get a divide by 0 here. So when you graph here, the biggest thing is I tell them is use 3 values above and 3 values below your excluded value, so we can get it in 2 different quadrants here when we graph. So the values that I've chose for x, we have -5, -4, -3. Those are my values below, my 3 values above. When you substitute in, you get -2/3, -1, -2, 2, 1, and 2/3. That's when you substitute in x for that original equation. So -5 plus 2 is -3. 2 over -3 is -2/3. Basically how it works. I want you to go ahead and plot your points. Here's what my plots look like from the graph. Now I'm going to go ahead and construct my lines here. Remember, when you're dealing with an asymptote here and you're using your points, it'll never touch the horizontal and never touch the vertical asymptote. So the line is going to continue on and never touch that. So your rational function should look like this. And there's your rational function graph again, not touching your horizontal or vertical asymptote. Same type of equation here in example 4. Again, to find that vertical asymptote, we'll use that denominator x minus 2. Set it equal to 0. Basically what you're finding is the excluded value. So x minus 2 equals 0. Add 2 to both sides, and x equals 2. And go ahead and graph that where x equals 2. Crossing the x-axis at 2. There's your vertical asymptote. Horizontal asymptote, y equals c. Here's that c value is 1. So y equals 1, and again I'm going to graph the horizontal. Crosses the y-axis at 1. Following this, you just want to go ahead and use your equation. Remember the value, the excluded value for x is 2, so we want to use 3 above and 3 below. There's my points. And substitute in -2. So when I put -2 in your equation here, notice we have a negative sign. So put in -2. -2 minus 2 is -4. So right now you have -1/4 because the denominator is -4. Then you need to include the negative sign. So -1/4 would therefore change to a +1/4. +1/4 plus 1 would give us 1 1/4. And to walk you through that again, I put in -1 for x. -1 minus 2 is -3. We would have 1 over -3. We then include the negative sign, which -1/3 would convert to a +1/3 plus 1, and we would come up with 1 1/3. Go ahead and work through the rest of your values, plugging in for x. 0 would come out to be 1 1/2. 1 is 2. 3 is 0. 4 is 1/2. And 5 is 2/3. Next step is to go ahead and plot these. Notice here that 2, the values I have 1, 2, 3, 4 values below 2, so I should wind up with 4 points in one quadrant and 3 points in another quadrant when I graph my rational function. So go ahead and plot them. Here's my points graphed. Notice it's in quadrant 2 and quadrant 4. Remember that your rational function is never going to touch your vertical or horizontal asymptote. It has that curve, so you can go ahead and graph it, and it should look something similar to this. And this will conclude our lesson 49, 9-1 on rational functions.